In this video, we're going to take a look at equivalent fractions. And if you understand equivalent fractions, then working with fractions is pretty easy. Well, what are they? Equivalent fractions are fractions that name the same amount. So here you have two fractions, 1/2 and 2/4, and they're naming the same part of that circle. 1/2 and 2/4 are equivalent fractions. They're naming the same thing. Now, when you're writing equivalent fractions, it's pretty easy if you can remember the identity property of multiplication, which states that any number times 1 will give you that same number. Its identity doesn't change. For example, if you multiply 6 times 1, you're still going to get 6. The 6 doesn't change. If you multiply 1/2 times 1, you're going to get 1/2. If you multiply anything by 1, its identity won't change. You'll end up with the original number. Well, that's real important. All of these fractions here are equal to 1. 11/11ths, 5/5, and so on. All of these equal 1, which means if we multiplied something times these fractions, it won't change the identity of that number. For example, if we took 2/3, all of these fractions right here are the same as 1. It's like you're multiplying times 1, which means you're not changing the identity of the original number. 2/3 is equal to 22/33. 2/3 is equal to 14/21. 2 times 7 is 14. 3 times 7 is 21. These are equivalent fractions. If you multiply 2 times 5 and get 10, 3 times 5 and get 15, 2/3 and 10/15 are equivalent fractions. And that last example, when you're multiplying by 3/3, it's like you're multiplying by 1. You're really not changing the identity of 2/3. 2/3 is equal to 6/9. In fact, all these fractions down here that we've created, they're all equivalent fractions. They're all naming the same thing. So if your teacher asked you to write 4 different equivalent fractions for 3/8, it'd be easy. We could multiply it 3/8 times 2/2, which is just like multiplying by 1. We're not changing 3/8's value. 3 times 2 is 6. 8 times 2 is 16. 6/16 is an equivalent fraction to 3/8. What about if we multiplied it times 4/4? 3 times 4 would be 12, and 8 times 4 would be 32. 32 is an equivalent fraction to 3/8. What if we did 10/10, which is the same as 1? That would be 30/80. 3/8 and 30/80 are equivalent fractions. And what about if we did, how about 10,000/10,000? Which is equivalent to 1. It's like multiplying times 1. That would give us 30,000/80,000. That's an equivalent fraction to 3/8. So we just made 4 fractions that are equivalent to 3/8. Real easy. Now let's take a look at these equivalent fractions and see if we can find the missing numerators and denominators. So if you look at the first one, 9 times 8 would give you 72. Well, if you multiply 7 times 8, that would give you 56. The missing numerator would be 56. 4 times 5 is 20, and 7 times 5 would be 35. That's your missing denominator. 8 times 7 is 56. Something times 7 is 21. It would be 3. 2 times 9 is 18. Something times 9 is 45. It would be 5. Now, there's a couple different ways you can tell if 2 fractions are equivalent, and we'll look at both methods. 4 times 3 would give you 12. Is 7 times 3 28? No. Those are not equivalent fractions. 5 times 8 is 40. Is 6 times 8 48? Yes, it is. Those are equivalent fractions. They name the same thing. We'll do a different method on this next one. First, 7 times 3 times 7 is 21. Is 10 times 7 30? No. Now there's another way you could tell if these were equivalent. If you cross multiply, you should get the same product. So 10 times 21 is 210. 30 times 3 is 90. These are not the same. Those are not equivalent fractions. Let's look at this last example. 6 times 6 is 36. Now, is 9 times 6 54? Yes, it is. Those are equivalent fractions. Now, this is an interesting question, and equivalent fractions can help you to answer it. Are there any numbers between 1/3 and 2/3? Well, when you first look at that, you say, no, there's nothing in between 1/3 and 2/3. Well, it's not true, and we can use equivalent fractions to help us. If you took 1/3 and you multiplied it times 8 over 8, which is like multiplying times 1, you would get an equivalent fraction of 8/24. If we did the same thing to 2/3, multiplied it by 8 over 8, we would end up with 16 over 24, which is also an equivalent fraction to 2/3. So instead of asking you, are there any numbers between 1/3 and 2/3, I asked you, are there any numbers between 8/24, which is the same as 1/3, and 16/24, which is the same as 2/3? You'd say, oh, well, sure, yeah, there are quite a few things between 8/24 and 16/24. And there's actually a lot more than that as well. But you can use equivalent fractions, can help you in so many different ways.